Let's look at some more examples of some problems here. I've got 3 examples, one each with horizontal and slant, and then one where actually I have 2 horizontal and then 1 slant. So let's take a look at this first one. We're looking for the domain, all the asymptotes, and the zeros. I'll start with domain. We need to find where the function is undefined. That will also help us get the vertical asymptotes as well. So factoring the denominator, setting it equal to 0, we should be able to find what our what our values are. We'll get 2 of them, negative infinity up to negative 5. We'll union that with negative 5 to positive 4, and then we will union that with 4 to infinity. From here, we can get our vertical asymptotes. We know that x cannot equal negative 5. We know that x cannot equal 4. So those are the 2 spots where we have a vertical asymptote. So simply by focusing on the denominator, where's the denominator equal to 0? Factor and solve, we clear up the domain and the vertical asymptote right away. Moving on to the horizontal asymptote. We know it's horizontal because the degree of the numerator is less than the degree of the denominator. And we know that when that happens, we get a horizontal asymptote, and it's y equals 0. This problem is coming together very nicely. Finally, the zeros. What values of x make this function equal to 0? We only focus on the numerator. What values of x make the numerator 0? Negative 3. So putting all this together, we have our domain. X is going to be any number except negative 5, positive 4. We have a vertical asymptote at x equals negative 5, a vertical asymptote at x equals 4. We looked at the degree of our function, the degree of the numerator, saw that it was less than the degree of the denominator. That means that everything in the numerator goes to 0 as x gets really large, and our horizontal asymptote is y equals 0. Finally, setting the numerator equal to 0, we found that the zeros, or the solutions, if you will, of this function, zeros of this function, it has 1, and that's x equals negative 3. From all of this information, we can sketch the graph of this function. And by sketch, I mean we can get a kind of sort of good enough picture. This is by no means a perfect picture, but it's a good enough picture. So here's negative 5, here's positive 4. Our function cannot cross those. Here is y equals 0. We know that in the long run, our function will approach that value. And here is a 0. Here is where our function is going to be crossing the x-axis. And that is the only place. So, putting this information together, we could sketch some points here. Or we could sort of sketch a kind of sort of graph. Since it only crosses the x-axis at this point, it's either going to come down kind of like this, or it's going to go up kind of like this. How do we know what it's going to do? Well, we really don't. So let's plot a few points. Let's pick what happens when x is 0. When x is 0, I get 3. When x is 0, I get negative 20. So when x is 0, y is negative 3/20. So that tells me it's going to sort of downward trend. So one guess is sort of like this. Now for the rest of it, I know that in the long run it's going to approach 0. I know this is x equals 4. Let me pick a number bigger than 4. Pick 5. When x is 5, I get 8. When x is 5, I get 25, 30, 10. 8 over 10. So when x is 5, I get this value right here. So that tells me it's probably going to do something like this. And then here would probably be the mirror image of that, like so. There's a rough sketch. Again, by no means is it perfect. It's here's an estimate of what the graph would potentially look like. Simply by using this information here, we get a good setup. We know that as x goes to infinity, this is going to come down and approach the x-axis. It's going to approach the x-axis from this direction. Rational functions are symmetric like this. So because I have this piece here, and then all we really need to do is plot 3 points to get a sense of the shape. Vertical asymptotes helped us get a sense of where it doesn't cross. Here's where it crosses the x-axis. All that information just from these 3 little boxes here. That's sort of the utility of these properties. Helps you come up with a kind of sort of graph. Next example. Same sort of function, rational function. Find the domain, find the asymptotes, and find the zeros. Again, we start with the domain. We want all the values of x that do not work. So setting that equal to 0. It appears that this is going to be a little tricky. As long as you remember your basic algebra, it's not too bad. We know that we can factor out 1 power of x. And from there, we see that we will get 3 bad values. X cannot be 0, x cannot be -2, or -5. So this domain is going to be rather long. A lot of intervals here. Interval from -infinity to our first spot, -5. We will union that with -5 to -2. We will union that from -2 to 0. And then finally, we will union that with 0 to infinity. There's our domain. 4 intervals. 4 intervals to choose values of x from. And then from that, we can pull our vertical asymptotes. We know x cannot be -5, x cannot be -2, x cannot be 0, and that is it. Those are the three values. And again, we have to write each one separately as its own equation. You cannot just do x equals -5, comma, -2, comma, 0. Because what you're saying in that sense is x is an ordered triple. X is a single point in three-dimensional space. And I just forgot the parentheses. No. These are lines and need to be written as lines. So each gets its own separate x equals. Nothing less than that is acceptable. We have our domain. We have our vertical asymptotes. Now we check to see if it's horizontal or slant. Degree of the numerator, degree of the denominator are equal. So that means we look at the leading coefficients. It's horizontal, and y equals the ratio of the numerator's leading coefficient to the denominator's leading coefficient. Y equals 3. Because we have a horizontal, we do not have a slant. So we've covered all the asymptotes. All that's left is to cover the zeros. And we do that by setting the numerator equal to 0. We can factor out a term of 3x. That should be 198. It's 198. Which that is 66, I believe. If I did that correctly. 3 times 8. Yes. And from there, we can factor, we can solve. I'll write these down here. X, or zeros are x equals 0. Don't forget about that 3x term out in front, just like algebra 1. And we would get -11 and +6. Yes. Zeros of our function, horizontal and vertical asymptotes, and our domain. And again, if we needed to, we could do a rough sketch of the graph based on that information. We know in the long run, our function will approach the line y equals 3. We have 3 vertical asymptotes, and we have 3 places where it crosses the x-axis. Final example. This function, and again, we'll find the domain, all the asymptotes, and zeros. Starting with the domain, we have one bad value of x. X cannot be 1/2. -infinity up to 1/2, parenthesis, not a bracket, union 1/2 all the way to infinity. Once the domain is in place, we can get our vertical asymptote of x equals 1/2. Degree of the numerator is greater than the degree of the denominator. So this is going to be a long division problem. You will have a slant asymptote, and we need to do some long division here to determine what it is. X squared, too far. X squared minus 10x minus 75. That is going to be divided by 2x minus 1. Again, because this asymptote is a slant, long division is our only option. So asking ourselves how many times, ask ourselves what times 2x equals x squared. The answer to that is 1/2 x. 1/2 x times 2x gives us x squared. 1/2 x multiplied by -1 gives us -1/2 x. Big giant minus sign, so we don't forget about it. X squared minus x squared is nothing, which was our goal there. -10x minus -1/2 x. -10 minus -1/2 becomes -10 plus 1/2 becomes -9.5, which we will make -19 halves. Now I need something multiplied by 2, something here multiplied by 2 that's going to equal this value. We'll go off to the side. Here's what's going on. Something multiplied by 2 is equal to -19/2. So the way we determine that is simply divide both sides by 2. Dividing by 2 is the same as multiplying by 1/2. We get that that something is -19/4. So that's our missing value. -19/4. 2 times -19/4 is -19 halves. And we're done. We have our mx plus b form. This is our slant asymptote. Y equals 1/2 x minus 19/4. So we have our vertical and we have our slant. What's left is to find the zeros of this function. Set the numerator equal to 0. And then we factor and solve. And there we have it. We have our domain. We have our asymptotes. And we have our zeros.